of Mechanical Engineering. My institute name is Mohanta School of Engineering, Baripada. Today we will study the friction chapter of term subject, that is bearing and clutches. This chapter includes bearing and clutches. What are the bearings? First, pivot bearing, flat pivot bearing. Second, conical bearing. Third one is collar bearing. Types of clutches. First one is single thread clutch. Second is multi-put left clutch. Third one is conical clutch. Fourth is centrifugal clutch. Now we will discuss about the flat pivot bearing. Flat pivot bearing. This is the figure. One shaft is rotating inside a bearing. There is a load W acting on the shaft whose radius is capital R. We take a elementary strip at a distance of R from the center with thickness here. Then what will be the frictional torque lost in this friction? Then that from the torque we find the power loss in friction. First, the area of the elementary strip. Area of the elementary strip dA is equal to 2 pi r dr. That is called area of the elementary strip. Then the force, frictional force dF is equal to mu into W. There are two types of conditions there. First one is uniform pressure condition. Second one is uniform wear condition. First we take the uniform pressure condition. Uniform pressure condition means the bearing is new and the force applied on the bearing surface is or load is uniform. That is called pressure P is equal to load W by total area of the whole section pi r square. That is the uniform pressure P is equal to C. and P is equal to C means pressure is constant and pressure is uniform throughout the whole section. The pressure will be same in the elementary strip also. Then we go to the second condition, uniform wear condition. Uniform wear condition. Uniform wear condition means the bearing is old and the rubbing velocity and the radius of the surface from the center is multiplication is constant, that is called PR is equal to C. Pressure into radius is equal to C and the bearing is old one. That where not P is constant and R also not constant, but their product is also product is constant. First we calculate the uniform pressure condition. Pressure force on the strip dP is equal to P into dA, means pressure into 2 pi R into dA. That is called pressure force. Now we calculate the frictional force. Frictional force dF. dF is equal to mu into dP. That is pressure force is equal to the normal reaction, and F is equal to mu m, that is the first formula of friction. So mu is here and dP is also written as P into 2 pi R dr. That is the total frictional force acting on the elementary strip. Now we calculate the frictional torque. The frictional torque will be dt is equal to df into distance from the center, that is r. So df means mu p 2 pi r dr, mu p 2 pi r dr into all again r. So now it becomes P 2 pi R square dr. That is the frictional torque lost in friction in the elementary strip. Now we want the total torque T is equal to integration of dt. Whole section total torque lost in friction is equal to integration of dt, limit from 0 to capital R. Limit 0 to capital R. Putting the value of dt, integration of 0 to r mu p 2 pi r square dr. Mu is constant, p is constant because p P pressure input pressure P is equal to constant. So 2 pi also constant. Bring that outside the integration. The integration constant is mu P 2 pi. R square here. Integration becomes R cube by 3. Limit 0 to R. Now total value becomes T is equal to mu P 2 pi R cube by 3, capital R cube by 3. Putting the value of limit because the lower value is 0. Then putting the value of small p, that is small p means pressure constant, total load equal to W by total area by R square. That is the value of P. So mu W by pi R square 2 pi R cube by 3. Pi cancel, R square R cube 1 there. So next 2 by 3 mu W R. You can we can write it also as W mu W equivalent radius or uniform pressure. Uniform pressure RE value is 2 by 3. That is the equivalent radius for uniform pressure, equivalent radius for the flat cover valve. Then we can go to the second condition, uniform wear. Second condition is uniform wear means PR is equal to C. Uniform wear. Uniform wear. Second condition. So torque DT value is same. That one like first one. Mu P 2 pi R square dr. DT value is same, the formula is same, and limit also same, but here P is variable, R also variable, but the product of P R is constant. That is, it is here different. So total torque in this condition, in this uniform wear condition, T equal to integration of dt limit 0 to R. Then we calculate the torque by putting the value of dt, that is same mu P 2 pi R square dr limit 0 to R. Here mu and 2 pi is constant. Mu constant, 2 pi constant. Bring r from the r square and multiply with p, that is pr equal to c. So bring mu 2 pi pr equal to c, integration of 0 to r, remaining r is there, r dr. So putting the value of mu 2 pi c r dr, limit integration is r square by 2 limit 0 to r, that is mu 2 pi c r square by 2. Here the value of c, again we calculate dw, then integration of w. Here w is not shared because the uniform molar condition, we need a second integration for w. Then we calculate the value of c from the second integration of dw. The load on the elementary stick, take load on the elementary stick dw is equal to pressure into elementary stick, pressure into dA is equal to pressure into 2 pi r dr. That is the load on the elementary stick. Load is variable here, so we need the total load is equal to integration of dw limit 0 to r. That is called limit 0 to r p 2 pi r dr. Here 2 pi is constant, but p variable, r also variable. But the product of pr equal to c, that is bring the all constant from the left side of the equation is 2 pi c. 2 pi c limit 0 to r dr. Here the 2 pi c integration of dr is r limit 0 to r. That is called 2 pi c capital R. So value of c is w by 2 pi r. The second equation. The value of second equation now put here from the for finding out the torque T. The value of C mu W C value here we calculate W by 2 pi r. W by 2 pi r into r square by 2. 2 pi cancel, r square cancel, remaining part is mu w r. This value is called equivalent radius for uniform wear condition. Stop. We find out that frictional torque lost in column bearing. Here is column bearing. There are two diameters. One is inside diameter D2, that is D2, and this one D1. So radius will be here R1 from here to here, and R2 is here to here. So limit will be now R2 to R1, and all the frictional torque and pressure is uniform wear, all are same. We calculate here the frictional torque lost in the column bearing. First one, uniform pressure E is equal to constant, which is column bearing is mu1. Then we find out the frictional torque dt in the elementary steel. Let here the elementary steel inside the radius of R2 and R1, whose distance is R and thickness is dr of the elementary steel. So area of the elementary steel, dA, area of the steel equal to 2 pi r dr. And pressure is uniform, so pressure in the whole section from radius up to R1, all the area pressure is uniform, so is load, total load divided by total area, means R square minus R2 square. That is called uniform pressure P is equal to constant. Where dt is same for the whole as well as flat column bearing. dt formula is mu p 2 pi r square dr. It is same. Then dt is the frictional torque lost in the elementary steel. We need the total torque lost in friction. So we calculate P equal to integration of dt. Here limit is different from lower limit R2 to R1. So that is putting the value of dt mu p 2 pi r square dr. Yeah, mu is constant, p is constant, 2 pi is constant, and integration of r square dr is r cube by 3. Mu p 2 pi r2 by 3 limit r2 to r1. That is the value of t. Putting the value of lower limit and upper limit putting the value of lower limit and upper limit. 1/3 is here, R1 cube minus R2 cube. 5 by cancel, 5 by cancel, and the remaining part will be there. Mu W 2 by 3 R1 cube minus R2 cube by R1 square minus R2 square. This is the value of T. When we calculate the value of T, we can calculate the power loss in friction. Power capital P equal to 2 pi mt by 60, where in that RPM, and for calculate from this formula. Thank you.